All right then. So big test on Tuesday, right? Today's the 24th. I think that's the 29th will be the test then, right? We gotta if to go from Thursday to Tuesday, you gotta add 5 days. So 10/29 will be your district assessment. And boy, oh boy, is it some free points waiting for you. So you need a grade boost? I got you. This test will almost feel like extra credit. It's so easy. Um, so the first section has four problems, and all you have to do is factor. That's it. No equals zero, nothing like that at all. And the factoring is pretty straightforward. So I'm going to run through five, six of these, whatever, just to kind of give you an idea as to what you have to do. So here's an example of um, what you can expect. When you consider the brutality of the factoring test you guys took a month and a half ago or whatever, this doesn't even hold a candle. This is written, no tricks, just very basic. So, yes, this is as easy as you think. This is just a quadratic, right? How would you factor it down? Yeah, do your two shells, your two sets. Yeah, and then we need our X's in the front. What are the signs going to be? Plus and plus, and what are the numbers? And that's it. So like there is the first problem on the test. Honestly, I kid you not, it's that easy. Okay. You get points for that. I know. Good, good. Any questions about that? The next question on the test is a difference of squares. Do we need to practice that anymore? What I just did? Okay. The next question is a difference of squares. So remember that a different, and I'll do a couple of these with you here. So remember that something like this is a difference of squares, right? And we've gotten to the point where this isn't something we focus on. It's just become a thing that happens at all whenever it wants to, right? But this is its own problem. And again, you get points for this. So how would this one factor down? Say again. Yeah, it's almost like a trick question. You think there's no way that this could be this easy, but remember with the difference of squares, we just create the plus and minus pattern that makes the middle term disappear. Remember that you'll also see differences of squares where there's a number in front. So for example, say we had like 16x squared minus 121, something like that. I still recognize it for what it is, right? It's a difference of squares. And the pattern that I use is identical. I'm still thinking to myself that I have to do the plus minus pattern to make the middle term go bye-bye. What's going to go in the fronts? 4x and 4x, right? This isn't one where we sit around and guess and wonder if it's 8 and 2 or whatever. Like we know with a difference of squares, it's formulaic. Like there's no thinking about this. And then what's the square root of 121? So you slap your 11s in there and then just make sure you give one of them a plus and one of them a minus. And of course, the order of the plus and the minus, it doesn't matter. So do you have any questions about that? Okay. The third question is has got a GCF in it. So it's going to look something like this. And again, on Monday, I'll have something actually typed. And whether I give it to you on paper or we just pull it up on Canvas, it'll be a structured, like formal practice. We'll take it in class and then grade it in class and all that stuff so that we're ready for Tuesday. Then we can move on. Noise. Factor. What is it? Yes. So we're going to pull out of all of these a 3, and we're also going to pull out an x. And what's that going to leave behind? 4x squared plus 4x minus 15. Everybody good there? And then the math problem now, as you know, because we've done this, I mean, I think I can honestly say hundreds, I feel like hundreds now of times. We understand that the math problem is the white problem now, right? And so there's a little bit of stress about this one. This is not certainly as easy as like problem one. There's no formula to this. What we have to understand now is that there are two potential sets of shells. These are always our least favorites. There's just no way that a normal person savors this process. Like it's just annoying, right? So what are the possible things that we could put in? Or, right, like we get that. And then what do the signs have to be? Yeah, there's got to be one of each. So at any point in this, and you start to doubt yourself. Remember, like we can try different things as far as placements of numbers and stuff, but the non-negotiable is like we're never going to say, well, let's try two minuses or let's try two pluses. Like we understand that that would just be stupid. It's literally impossible to multiply to make -15 at the back if there's two of the same, right? And then the guessing game begins. Any of you little wizards figure it out?
It's gonna be the 2x one.
You sure, huh? You sound pretty confident. Okay. You want the 5 and then the 3? Three first, 5 second. Yeah, and you guys have gotten to the point now where you're starting to just do these by inspection. You're doing all the math mentally. You're envisioning it working itself out. And so, the days where we would try and erase, we're just really not there anymore. You just kind of look at it and you can see it happening. And you know that this works because these make -6x and these make +10. And -6 plus 10 is exactly what we wanted for. And so the answer, you just have to be careful in a problem like this that we, myself included, we humans tend to think, yay, I found it. And we forget about that guy. So make sure that you bring down your GCF because that happens a lot. So do you have any questions on that? All right. The last one, again, I'm not like being cryptic about this. The fourth problem, the last problem in this section, I'll just straight up tell you they're cubes. So we need to be really good with sums of cubes and differences of cubes. So remember that there's basic cubes like this one. And then there's more complex looking cubes like this one. But what we recognize through lots and lots of practice is that we know they're both cubes, right? Like we get it. And, that sheet that you have with all the cubes and stuff on it, you can have that out on the district assessment too. And the same rules apply. You can have your normal 8.5 by 11 page notes, front and the back, put whatever you want. But you can also have those other resources that I've told you you can use, the 2 cheat sheets that I gave you. So you probably have your cubes memorized by now, some of you. But if you don't, that's okay. So let's do the easy one first over here on the left side. What is A on the left side? A is X. Yeah, just like 1X, right? Just X. Remember, A and B are always the cube roots of the things that you see. So A is X. And what is B? Good. And then at this point, really, it's just a matter of either you've done it so much that you've memorized it or you have the short set, long set formulas in your notes. But this one, since it's a plus, is going to be short set, long set with a plus here, and then minuses, minus and then plus like that. So remember that the short set gets whatever sign the original problem has. And if that's a plus, then the minus gets booted to the middle. Okay, so let's plug stuff in. What's going to go in short set? X plus 2 and long set?
Yes.
X squared minus 2x plus 4. So maybe you'll see a problem just that easy. Okay, maybe not. So let's take a look at just a slightly, bless you, a slightly harder scenario, the one on the right. We're still in the same mindset. Look for a GCF, quickly figure out there isn't one. So we're going to go back to, again, finding A and B. So what is A on this one? 5x. Good. Remember, you got to cube root both parts of that. Cube root the 125, cube root the xy part. And then what is B? 216 is 6. 343 is something else. 7. Again, if you memorize those, great. If you don't, no harm. But there we've got our A and our B. Critical. And then we build our shells. And this one, we're going to do short set, long set, but just be aware again of the signs and how they play. If the original problem is a minus, then the minus will get spent right away. And then everything else clear sail and pluses, right? So it's either plus minus plus or minus plus plus. Just depends on what the problem is. What's going to go in the short set? Yeah, just A minus B, 5x minus 7. And this, I mean, there's a couple of places on this test where I think mistakes could be made. But I mean, here we are talking about it for the umpteenth time. So I'm telling you that this one right here where this arrow is pointing potentially could be a hot spot for mistakes. So just watch out. What goes there? Huh?
25.
Right. And just here's the things that I would see. Like these, as a teacher, these are the wrong answers that I don't want to see, but if I am, I expect it to be this. A lot of people put 5x squared. What's wrong with that? I didn't square the 5, did I? Or another mistake is the one that you just heard yourself say, and that is that we get in a hurry and we put 10x squared, right? And we forget that 5 squared is 25. So while it is a pretty simple test, we're not immune to still making little stupid human errors. So 5 squared is 25 and x squared is, well, x squared. Okay. Be solid there. What's going to go in the center? 35x. And remember that that's just the A and the B multiplied together. And what's going to go in the back? 49. Simple. Straightforward. No trickery, no subterfuge. There's no one's trying to get you. It's just a bare bones test of do you know how to do cubes. So any questions on the top portion? 4 questions on that. Kind of just went through what they all are. In the next section, it's still a factoring thing, but it's solving now. So the directions will not say factor. The directions will say solve by factoring. So you're still using factoring. It's just that factoring isn't the be all end all. It's a means to the end, not the end. So for example, you could have 3x squared minus 5x minus 12. And the difference here is that we're going to have function notation. So the directions don't say solve. It uses the terminology that we've been using a lot lately. Like you should totally be used to it. The directions are going to say find the zeros by factoring. And there's a few other words in there, but this is the meat and potatoes part of the instructions. So what it really means is we're just looking for the places where the function crosses the x-axis. In other words, where f of x equals 0. So really what it boils down to is it's just a simple quadratic equation like that. Okay, finding the zeros quite literally means to replace f of x with 0. It's the whole entire purpose. So we factor. So remember, please, to try to be aware of keeping your equals 0 around. I try not to like bust people for this, but it's pretty unhealthy to act like it's not there. So try to remember to keep it there until you're done. So just instinctively write it down. The factors, this is just a standard quadratic, so we know the factors are going to look like this. What are the signs going to be? Yeah, again, one of each. So you just put them in there, do you have to switch them? That's what erasers are for. And then 12 has a bunch of factor pairs, 6 to be exact. 112, 12, 1, 2, 6, 6, 2, 3, 4, 4, 3. Did I say 6? Yeah. So what do you want to try?
3.
Like this? Sure.
But
Yeah, switch it, never mind. I mean, but that's what factoring is all about. Like there's no shame in having to turn your pencil around and erase it, but you try this and you realize that, you get 3x and minus 12 and you're like, oh crap, that didn't work. But it's, again, no harm, no foul, right? So then we realize I probably should have those in maybe a different order. So let's try putting the 4 and then the 3. And the whole dynamic changes because now the green ones make 4 and the purple ones make -9, and 4 minus 9 is exactly what we want. So the zeros are, remember, the things that make these equal 0. So what 0 do we get from the first factor? -4 divided by 3. And if you ever forget like why that works or like how did you get that, I've shown you this before, but I feel like I can empower you as you take other classes and maybe you take math in college and you ever forget, just remember the process of finding these is just take the 0 or take the factor out and just do what you want, set it equal to 0, and then just watch yourself solve the equation and you'll see where those answers come from. Like you subtract 4, you get 3x equals -4 divided by 3, x equals -4/3. Obviously, you don't want to do this much work every time. It's kind of a pain, but it's there if you forget. And then the other one's pretty easy. What do we get from x minus 3? So that is what we're expecting from you on problems 5, 6, and 7 is find the zeros by factoring. So set it equal to 0, do your thing. No quadratic formula necessary, just factor. Actually, I don't think you have to do the quadratic formula on this entire test. So for some of you, that might be better news than others. But there's very little meat on this bone. All right, on to the next problem. We're still on the same section. The directions still apply. Find all the zeros by factoring. The next one is something like this. And again, please respect the directions. It does say by factoring. So if you do it a different way, I gotta bust you. So sorry, but everything's nice and pretty easy factors. Like there nothing to it. What is this thing? It is. So we're going to replace the h of x, the name of the function, with 0. And then we're going to do our thing. Keep that 0 around. And what does 9x squared minus 1 factor down into? +1 and?
3x minus.
Right. That's it. Standard basic difference of 2 squares. What 0 do we get from here? Yeah. And this one? Yep. So if you wanted to just put a box around that, that's perfectly fine. Some people like to do things different ways and they ask the question, would it be okay if I wrote my answers as positive and -1/3? Of course. So you decide. It doesn't matter. Any questions on that one? Okay. The last one in this section, what changes is, well, you'll see. Let's call it g of x. And we're going to call it like x to the 3rd minus 5x squared minus 14x. So I'm going to do what I know I'm supposed to do and at least just put in a 0. And then what? Tell me about the factoring.
Plus and minus.
Exactly. We got to get that GCF out of there. I like it when you answer questions while you're yawning. It's always fun for me, at least. I don't know. Yeah, we got to pull out GCF. Like, and I agree that eventually we're going to talk about the signs, but right now the key is get that X out of the way. So if there's a GCF, you don't want to miss that guy. So we pull X. There's not a lot to pull, but then we're left with x squared minus 5x minus 14. And then you just keep the equal 0 rocking. That guy just hangs around, right? Just sticks around. So we still have GCF. And then like Mari said a minute ago, put your X's. And then we know there's one of each, 1 plus, 1 minus. And what are the signs? I mean, what are the numbers going to be? 2 and 7 in that order, right? And if you did it with 7 and 2, you'd realize that you got a +5 and not a -5. So you want to put the weaker number where the plus is and the stronger number where the minus is, get that balance correct. Always check it to make sure it works. And then what are the answers that we get? Yeah, and a popular mistake. Yeah, a popular mistake, I can tell you. I'm just trying to read the future here. This would be a popular mistake, right? Don't forget that the GCF in this case is not trash. Sometimes GCFs are trash. Like if we just pulled out like a dumb 3, it doesn't have any bearing on the answers. But when the GCF has a variable like this one does, then you always get an answer of 0. Okay, so don't forget that. And you could kind of remember that just based on the fundamental theorem of algebra, which states that, hey, if the problem starts as a degree 3, then you better get 1, 2, 3 answers, right? Make sure those match. Any questions on any of that? Okay. The last problem is it's its own page, and it's not because it's probably going to take you a whole page. It's just this is more in line with sort of a combination of a couple things we've been working on. So this problem brings together the concepts of synthetic division, rational root theorem, positive negative intervals, end behavior. So this one problem, number 8, sort of is it's a big package. Not a difficult problem, just there's a lot of meat on this bone, number 8. So I wrote a couple of examples for you for this. And so we'll just run through these and then I think we'll be done for the day. So you're going to be given a function and you're going to be asked to find and graph the zeros. And then graph the function, to make the whole graph, and then name the intervals over which the function is positive or negative. So the directions don't explicitly say everything you have to do, but implied in there is there's a lot of stuff I need to know how to do. So here's an example for you. So heading into this, how many answers are we expecting? 4. And as, any teacher at this level would agree, we're going to always give you enough to get you down to where you can factor. This is not a thing that we would try to factor, right? We don't factor in that sense. We sort of factor by using synthetic division to chip away at the stone until we can pull it down to where we're comfy. So we're going to start by thinking about, okay, rational root theorem. Remember that means that I have to take the factors of the number in the back and divide them by the factors of the number in the front. And we love the problems where there's no number in the front because that means that all of our potential rational zeros are whole numbers, integers. So the possible rational zeros are positive -1, positive -2, positive -3, positive -4, positive -6, and positive -12. Good. And so since we have the advantage that we can't do this on Tuesday, but we have the advantage right now as a class of having 14 or 15 of us all collectively working together. So we're going to, first off, remember the purple numbers. The numbers that are in front of the problem are our synthetic guys. So we're going to start by just building a workspace. 1, -3, -9, 23, and -12. We're going to get our workspace all set up. And then we're going to start testing numbers. And it looks like Kaysen worked ahead of us and found one. So that's a big help for us. So we're going to trust Kaysen on this. He generally knows what he's doing. So when we use the 4, let's see if Kaysen's correct here. So 4 times 1 is 4, -3, 4, 1, 4, -5, -20, +3, +12. Spot on. So we could say 1 down, 3 to go. We have an answer. Remember that one can work again. So this question came up, bless you, like over a week ago. I think someone asked the question, could the same answer occur twice? And the answer is, yeah, it could. So I would, while I'm there, maybe just quick check 4 again, make sure it works or doesn't work. And then you can call it done. Anyone find another one? Remember the list of zeros is still the same. Like we're still pulling from the same pile. So 1 works. Let's try. So we're gonna again synthetically staircase that thing down like that. Let's try a positive 1. 1, 1, 1, 2, 2, -3, spot on. And here we go. And as you saw on yesterday's quiz, like you're empowered at this point. You have options, which is nice. The 3 numbers that remain are the coefficients of a quadratic, right? It's x squared plus 2x minus 3. So at this point, you could continue with synthetic. You could factor maybe. You could quadratic formula. You have all sorts of options. Anyone notice anything? It is. It's factorable. So we actually don't have to touch the quadratic formula here because we know it's pretty obvious that the factoring on this is like super easy factoring. X plus 3, x minus 1. Bam, just like that. And that's super sweet. There was one question on your test like that, right? You might remember. I don't think everyone caught it as factoring, but then some of you plugged on through the quadratic formula just to realize at the end, this is the one where the pathways happen, where the roots go away. So anyhow, these we're done. Like now we just got to collect all the answers together. So from before, with your guys' help, we found 4 and 1. So the answers from before were x equals 4 and x equals 1. And then and we also got an x equals -3. And then what else? And we got another 1. And so what we want to do in a case like this is actually put a little parenthetical comment next to the 1 and say, you're a ×2 guy. I would, just because it's going to affect our graph. Yeah. And if I didn't care, I would tell you, just don't worry about it. But in a case like this, I care just because what's that going to mean now when we go to make a graph of this? It's a bouncer, right? And I don't want to miss a chance to see that. So I'm going to think you should write it that way. If it happens, if it doesn't happen, then don't worry about it. So now this is where yesterday's quiz would have stopped, but this quiz, this district assessment takes this is why it gets kind of one whole page here. Like, because now instead of saying, oh, this is the end of the problem, now I got to go make a graph. And so let's take a look at the graph. First off, going all the way back to the beginning, what is the end behavior going to be? High, high, up, up, right? And so that's going to help us to know. And so when I build my graph, I always start with my my x-axis, and then I place the y-axis sort of proportionally where it wouldn't be dumb. And I feel like this location feels pretty good. I got to give a little more love into the right side because I got to make it out to +4. So I'm going to just space these out. There's 1, 2, 3, 4, and then -1, -2, -3. So make sure you always label your x-axis, please. Yeah. All right, we made it. So now we're going to put all the pieces of the puzzle together. We used all the skills from Unit 1 in this one problem here. And we're going to put marks on our x-axis where the zeros are. So the zeros occur at 4 and at 1 and at -3. And you guys told me that the end behavior is high, high, up, up. So just that one little visual cue ought to get us going on this. So something interesting is in this graph. Where does it happen at? At the 1, right? That's a bouncer. And it's that bounce that actually saves our bacon, right? Without that bounce, this graph structurally couldn't happen. It wouldn't make any sense. Like you can't do certain things. But if we have a bounce at 1, then it all comes together. Like the puzzle pieces fit together. And then the graph is able to do what we want it to do like this. So again, that bounce really saves the day. Last thing on this problem is to describe the intervals where the function's positive or negative. So it's been a hot minute since we as a class have discussed this, but remember that positive intervals are above the x-axis. Like this is a positive interval and this is a positive interval. And then the negative intervals are below the x-axis. Overall, how many intervals are there? Nice job. I'm so proud that you guys didn't want to say 3. Thank you. Why do there have to be 2 separate intervals on the bottom? Because it touches 0, right? And when you touch the x-axis, you are no longer considered negative or positive. So good job, you guys. I'm proud of you. So we have to just now acknowledge all 4. So I always start, when I name my answers, I always start with whatever one is furthest to the left. If you were to look at my answer keys, half the time you'd see red first, half the time you'd see green first. I just go with left to right. So I'm going to start with positives. So remember the lingo, it's been a while. Positive over. Nice job. So negative infinity to -3 and 4 to infinity. Good job. And remember that these sorts of problems always get the rounded brackets because the numbers where the graph touches the x-axis, they don't count as parts of our intervals. Because like Kane said, when you're on the 0, you're not negative or positive. And then we got to do our negative intervals. And again, there are 2 of these. What's the first one? -3 to 1 and 1 to 4. And that's it. Like we did everything that problem wants us to do. It's worth more points than other things, but that's because there's a lot to do. You got to factor, you got to find your zeros, you got to understand end behavior, multiplicity, intervals, the whole shebang. So I do have one more of these, and I don't necessarily know that we're going to have time to finish it, but I just thought I'd give it to you so that you can, because I have 5 minutes. That might be enough time. I don't know, but I just wrote 2 of them because I didn't want you to just assume certain things about the problem based on one example. So the other one is a function, again, simple. And honestly, I didn't mean to use 12 twice. It's just the way I wrote these. It just happened. So that I mean, 12 isn't like, I'm not trying to imply anything. In fact, the number on the test is not 12. It just happens the ones I wrote. I wasn't even paying attention. So we start with making a list of candidates. And again, because there's a 1 in front, we don't have to worry about any fractions. And that'll be the case on the test too. No, I don't feel bad telling you that. So this should be straightforward, basic, bare bones. So what are the possible roots are the same again, aren't they, right? So positive -1, 2, positive -3, positive -4, positive 6. There. Okay, so now we're going to do our synthetic thing. And then the numbers are 1, -2, -7, +8, and +12. And here we go. So what'd you find? 2. Yeah, give me input so we can get through this. 2, 0, 0, -7, -14, -6. There it is. Thank you for the help on that one. So we got 1 down, more to go. Hit me up with another one if you find it. Okay, let's try -2. We're going to drop this down, boom, -2, -2, that's 4, that's -3, that's +6. And if you found a different one, what you're seeing is that that's because there's all rational zeros. So I'm just telling you now that there are no quadratic formula irrational things on this test. So the 4 answers that I had coming into this when I wrote this morning were -1, +2, +3, and -2. So the thing is, we as a class just happened to find 2 and -2 first. But Stephen might have found -1 before we found -2, or so, like, who knows? And so the point is, when they're all rational like this, the rational root theorem / synthetic division part is like freaking like Fortnite battle royale. It's just chaos. Like, you can do whatever you want. And so, I mean, at the end of the day, once again, we see factorability here, right? We have 1x squared minus 2x minus 3, which again should be well beneath your skill level. Yeah. And then there's those other answers, popping out. And again, they could have happened in any order. Like Estesha and Irene both do this problem and they both get all the zeros. There's a high probability they did these in a completely different order from each other. They're all just going to pop out though. So the answers are there and so they're written over here and then it's time to do the graph. So what is the end behavior again? High, high. What's different though about this graph and the other graph? Nothing bounces this time. So the structure of it's going to feel a little bit different. So let's just get in and make a quick sketch. So we got to go negative, 2 to 3. So again, give a little bit more love into the right-hand side. So we got -2, +1, +2, +3. And could you tell me what those zeros were again? Do you remember? -1, 3, 2, and -2.
Yeah.
And with the end behavior being up, it's pretty, I think, unmistakable how this graph's going to behave at this point. So it's going to go down here. It's going to go up through here. It's going to go back down through here. And it's going to go up through here like that. So that's super bad graph, but you get the idea. So we respect end behavior and multiplicity, and whatever the graph says to do, we just do. And if it doesn't work, that means you did something wrong, right? So how many intervals do you see here? 5, right? 3 of them are positive intervals and 2 of them are negative intervals. So there you go, dudes. So I'll type one up and have something official for you on Monday, but plan to take this test on Tuesday.